All right, let's continue on. So we just figured out B to C. Now let's go C to D. No problems there. C to D, now we notice that it does have work because there is area under the line. I'll just make a little line there to separate our work. What do we got? C to D. Alright, so we can start this one with whatever we want. I'm going to go with the change in internal energy equals 3/2 nRT. And our change in T, delta U equals 3/2 1 mole, 8.31 joules per mole times Kelvin. Change in temperature, we go from 400 to 200. 200 minus 400 is a negative 200 Kelvin. That comes out to be a negative 2,493 joules. Circle. I like my circles. Next, you can figure out either the work or the Q. I'll just go with the work. So the work equals negative P delta V. They don't give us the pressure or the volume. So we can just substitute in like we did over for there. We can substitute in another equation for that ideal gas law. So we'll go negative N R delta T. Work equals negative 1 mole, 8.31 joules per mole times Kelvin. Change in temperature is negative 200. So it's the same thing as up here, minus, or without, not minus, without the 3/2. Work equals, and this time it's going to be positive, which of course makes sense. Of course it makes sense, right? Because in order for a gas to do work on something, on the environment, it has to expand. And this time it's not expanding, it's condensing. So obviously work is being done, to the gas. And then we'll just finish C to D off. Change in internal energy is work plus Q. We have work, internal energy, internal energy minus work equals Q, negative 2493 minus that little guy there equals Q. Let's see what it equals. That is a negative 4,100, and I can't read it, 455 joules. Cool. So we got one more. Ran out of space on this paper. I'll add these guys to the table. All important table. Negative 2493. Work is 1662. Negative 4155. Another piece of paper. So now two more to go. We'll go D back to A. Now again, we're an isochoric process, so volume is not changing. So work is, and there's no area underneath D to A. So we can conclude that there is no work being done by or on the gas. Work equals 0. Freebie. Then we can calculate internal energy. Again, 3/2 and our change in T. Delta U, 3/2, 1 mole, 8.31 joules per mole times Kelvin. Change in temperature, we're going from 200 to 400. That's a positive 200 Kelvin. Delta U for this is 2493 joules. And then we use the first law of thermodynamics to get Q as work equals 0. Delta U equals Q. Delta U 2493 joules equals Q. Put those values into our table. 2493, 0, and 2493. All right. Now, very last, we just have to add all those up. And obviously, since we start at A all the way around and end at A, we do not change isotherms because A is the same point on the same isotherm as A. Duh. So the change in internal energy is going to be 0. That's important. And if we add all of these together and all of these together, obviously because delta U equals work plus Q, delta U equals 0, work is going to be opposite of Q. So if we find Q, we find that to be 1,662 joules. So work is obviously the opposite of that. And what does that mean? Well, since work is negative, that means work is being done by the gas, and that is good. That's what we want. That's why we care about this, because when we input heat, we get out work, and that is what we call a heat engine. And you can also tell it's a heat engine. The little cheater way is because in the PV diagram, the arrows are going clockwise. If it was going counterclockwise, it would be a refrigerator. All right, thanks.